Hey, working with graphs of sines and cosines. You had problems on page 53, 1 to 8. Now, some of the problems that they have on here are a little bit, the values, like for example, number 4, you have an vertical horizontal phase shift of 6. The period, it's not going to be nice to be able to graph. I'm not going to be going to that extent in regards to the niceness or the ugliness of graphs. The types of graphs that we went through and we've gone through up here are the types of graphs you'll see. You'll see phase shifts of 30, 60, 90. You'll see those types of phase shifts. You'll see the period is going to be 180 or 120 or 270 or 360. I'll give you ones that are a lot easier to graph and deal with, not deal with a phase shift of 10 degrees and then or a phase shift of 17 degrees. I won't go to that extent. Number 6, when you get large numbers where you have horizontal or vertical phase shift of 1,000 and amplitude of 3,000. I'm not going to go to that extent. Okay, so as we go through these here, there are certain limits that I will do. A problem like number 3, I won't even go that large with respect to my horizontal vertical phase shifts. I'm sorry, my vertical phase shift and amplitudes. A problem like number 5, something like that. Those are the types of problems I'm going to extend to you. I'm not going to go to that level of sort of ugliness in regards to graphs. I would 3 or 5 is either of those a good problem to do. It does not matter. Bless you. I'm trying to, like I said, I'm trying to get through not having to deal with the ugliness in regards to the problems. Do you want me to go through a problem right here in regards to it, or how we feel? We should hopefully feel a little bit more comfortable, bless you, than we have in the last few days. Yes. Number 5, we have y equals 3 plus 5. By the way, and I'm going to learn the rules of this because I don't know the dog cafe rules in regards to what's going on with these, with those things. But this may not exist anymore. I have to, once again, I need to know the rules in regards to what they're doing with respect to that, the coffee and stuff like that. I'm not a person that likes to have coffee in the classrooms. If you have a bottle of water here in the classroom, but I'm also trying to be a good soldier. If it's a program that the school is promoting and allowing to do, I'm going to allow to do that. But it's one of those things where I will check into this. I don't know the rules, and the rules have not been presented to me, so I will check into the rules and the regulations in regards to the what.
I talked to Mr. Black about it, and he said that they're trying to make it so that everyone will have a study hall to get coffee at some point during the week, or at least once a week, and that's when we can get it, but people don't have the classroom.
Okay, and like I said, those are details that need to get worked out. I'm fine with it today. Like I said, I'm being a good soldier about this, but rules need to be defined in regards to what has to go. Because once again, if you have a bottle of water in here, I don't mind those things, but I've never been a full person with respect to coffee. If we take a look at problem number 5, we have y equals 3 plus 5 cosine. Three plus 5 cosine of 1/2 theta plus 90. Okay, and if you have not done this, you should be doing this right now. Okay, this being a yeah studier is not going to work in this classroom as before. Okay, you need to find amplitude. If you haven't done it, once again, put your amplitude, period, vertical, horizontal phase shift. Okay, these things, and also the y-intercept. Okay, once again, y-intercept, put 0 in for theta. Okay, find the amplitude, determine the amplitude, determine the period, vertical phase shift, horizontal phase shift, and the y-intercept. Once again, these are the first steps every time that we've done the problems that we've gone through. Found the amplitude, found the period. You could use those. Amplitude you can find by inspection. Period, you're going to have to do one little clickety-clack in the calculator. Vertical phase shift, horizontal phase shift should be able to go by inspection, looking at the equation. Y-intercept, you put in the value for 0 for theta. So you have 3 plus 5 cosine 0.5 times 90. Close your parenthesis out. Okay, first off, the amplitude period. Kyrie, what do you have for the amplitude? 5. What do you have for the period? Okay, 360 divided by a half, we get 720. That is correct. Sophia, vertical, horizontal phase shift. 3 and negative 90. Once again, this is theta minus a negative 90. We ching boom this, and then y-intercept. You clickety-clack in the calculator. 3 plus 5 cosine 0.5 times 90. Close your parenthesis out. Adessa, what do you get for the y-intercept? 6.5. We good with all those numbers? All right. Now we start taking a look at the graph. Okay, I take a look at my graph. I have an vertical phase shift of 3 upwards, and I have an amplitude of 5. That means I need to stretch upwards a little bit more. Need to be a little bit more top heavy with my graph. Okay, I have a vertical phase shift of, or horizontal phase shift of negative 90, which means it's going to take me to left. I have the period of 720, so I need to have small 90s. Okay, so my graph, I need to be a little bit more top heavy with respect to my graph. I need to make sure I stretch up to 8. And like I said, I have 720 and 90, so I need to make smaller 90s here. But I can count out by 90s. 90, 180, 270, 360, 450, 540, 630, 720. Okay, first thing we draw in. First thing we take a look at. First thing we draw in is what? Donna? Prime axis. And we look at what for the prime axis? That's correct. What do we look at? What value tells us where to put the prime axis? I'm sorry, what? Okay? The vertical phase shift. Okay, so we take a look at their vertical phase shift. It will tell us to draw in the prime axis. So at a value of 3, we draw in our prime axis. Second thing, We take a look at our horizontal phase shift, our theta start value, and our trig function. Tells us where to start our theta. And the trig function tells us to start at peaks and valleys are on the prime axis. Okay, so we have at -90, we have a cosine curve. Is this peaks and valleys or prime axis, Joey? Peaks and valleys. So we'll have to take one additional step and look at the amplitude, because the amplitude will tell us how to get to our peaks and valleys. So at -90, from our prime axis, we have to go to a peak. -90 is our theta start value. This is our theta start value at -90. From our prime axis, we have to go to a peak. So we're at 3 with our prime axis. We have to go to a peak. Okay? So if I have an amplitude of 5, Grant, what's our y value going to be? At a value of 8. So we go up at -90 at 8. We have to go up 5 the amplitude. Third thing, we take a look at the period. Tells us where we will be at the exact same spot again. So if we start at -90, the period is 720. What is the degree measure for being at the exact same spot again? Nolan? 630. So at 630, we'll be at the exact same spot. So at a value of 8, at 630 and 8, we'll be there. Once again, an easy way mentally how to get through this, if you're a student, you get into a routine of what you do, just take your horizontal phase shift and add the period to it. -90 plus 720 gets me to 630. Now we start playing our games of halves. Halfway between -90 and 630. Between any two peaks will be a valley. So we first find our theta value. Find our theta value. Halfway between -90 and 630. Abby, what do you have? What's the theta value? Yep. 270. So we take -90 and 630. That gives me, okay, -90 and 630 gives me 540. Divide that by 2 gives me 270. Now the y value. What's the y value? Well, between any two peaks, it has to be a valley. Well, the valley, once again, goes from your prime axis. So my prime axis is at 3. If I go to a valley, Laura, where's my y value going to be? I have to go to a valley from 3 for my value of 3. My amplitude is 5. What does that take me down to? -2. So 270, we're at -2. Halfway between a peak and a valley, our gains of halves. Halfway between peak and valleys, we're going to cross the prime axis. Or a valley and a peak will cross the prime axis. So the next two with the cosine curve is going to be the two gains of halves are going to give me where I cross the prime axis. Chloe, what's those two theta values? 90 is one. 450 is another. Look at my y-intercept at 6.5. Put my y-intercept at 6.5 in, and it should be a nice little flow for my cosine curve on my graph. Once again, you should start to feel more comfortable. Are you perfect at them yet? Probably not. but you should feel more comfortable. The cues that I'm giving you, the questions I'm asking you, you should feel comfortable in regards to, oh, I understand what he's at least saying. I might not still be able to execute it, but I feel comfortable with what he's saying because I understand what he's saying now. The terminology I'm using in the horizontal phase shift, or the phase shifts and the period and the amplitude, the peaks and the valleys, those things should be a lot more comfortable to you now. Today what we're going to do is we're going to put the process in reverse. We're going to have a graph, and we're going to now develop the equation by looking at the graph. But these things are going to be exactly the same. We're going to follow the same method of madness. The cues I'm going to give you are going to be the exact same cues. It's just going to be, you're going to have to go by inspection now and looking at a graph. We still have the base equation, y equals vertical phase shift, plus or minus the amplitude, sine or cosine, b, theta minus horizontal phase shift. We still have that same general equation. We still know the period is calculated by 360 divided by b. That information is not changing because we're still dealing with a sine and cosine curve. But what now is occurring is I'm going to give you the graph, and what you're going to have to determine from the graph is these values. By looking at the graph and go by inspection. This usually helps students also, reassures what we've been dealing with and reinforces what we've been dealing with here. First thing we took a look at before was the prime axis. We drew in the prime axis. Well, we have no prime axis here, so let's draw one in. Well, let's take a look at the graph. Where would I draw in a prime axis here? If I take a look at my hashes here, let's see, this is -1, 1, 2, 3, 4, 5, 6. Where would we draw in a prime axis? Now, once again, you have to remember back to what does the prime axis do? What does it look like on a graph? Where would we draw on a prime axis? At a value of 5. So our prime axis, we would draw in a prime axis up here, correct? Is that what you're saying? So that's what we're going to oscillate about. Think about what our prime axis was. If we looked at this one, here was our prime axis here. We went up from it, we went down from it. We look at this prime axis, do we go up from it, do we go down from it? At a value of 2. Let's see what that looks like. No, tartar sauce. Okay, let's throw it down to 2. Okay, does that look like it's something that we go up from and go down from? Yeah, because we have to make sure that we're equal up and equal down. Okay, so if I'm at 2, I'm going up to 5. I'm at 2, I'm going down to -1. So am I going equal up and equal down? Yeah. So that would be my vertical phase shift. My vertical phase shift would, I guess I could go under, it doesn't matter. Vertical phase shift is a value of 2. I'm still looking for the amplitude, I'm looking for the period, and I'm looking for the vertical phase shift. Okay, I find my vertical phase shift at 2. I guess horizontal phase shift, my bad. I'm still finding those pertinent informations. Don't have to do the y-intercept. But the next one is a natural one to fall out of. I draw in my prime axis. The next easiest thing to find would be our amplitude. What would our amplitude have to be? If I drew in my prime axis here, What's our amplitude have to be, Raylan? Value of 3, because I'm going to go up 3 or I'm going to go down 3. So I have an amplitude of 3. The next thing is to find the period. Well, to find the period, we can go from peak to peak or valley to valley. That's usually the easiest, because those are critical values that are given typically in a problem. If I would go from valley to valley, or peak to peak, or peak to peak over here, does not matter. This is the period. What's the number of degrees from peak to peak or valley to valley? How many degrees are we going to go if we go from peak to peak or valley to valley? Brendan? 180 degrees. I have negative 60 here. I go to 120. Negative 60 to 120, that's 180 degrees. Or I go from 30 here to 210 over here. So the period is going to be 180 degrees. Now what we need, though, is we need to know a B value. The period is 360 divided by B. If I multiply both sides by B and divide by the period, the B value is calculated by 360 divided by the period. Well, we just said the period is 180 degrees. So the B value page would have to be what then? Now my period is 180. Okay, so 360 divided by the 180 gives me the B value, which would be what? 2. So the B value would give me 2. Now the last thing is the horizontal phase shift. Now, there are infinite number of solutions to these problems. Infinite number of solutions. My suggestion, and this is just my suggestion, in 99% of the problems or 95% of the problems, doesn't really matter, it is just the easiest thing to do is to go to your closest peak. Find a peak. Because if you have a peak, when you're at a peak, this is a positive cosine curve. And your trig function that you can use with respect to your graph is a positive cosine curve. So if I utilize this peak here of 30 degrees, this could be your horizontal phase shift. So if I look at my equation, we have y is equal vertical phase shift, which you said was 2, plus, since I'm going to a peak, that's a positive cosine curve. My amplitude, which is a value of 3. Cosine, because I'm going to my peak. My B value, which is a value of 2. Theta minus the horizontal phase shift of 30 degrees. If you go to a peak, this will be always a positive cosine curve. Now, once again, there's an infinite number of solutions here. Suppose you want a horizontal phase shift of negative 60. If you had a horizontal phase shift of negative 60, you went to this. Now you're at a valley value. Now you can write the equation y equals 2 minus 3 cosine 2 theta plus 60. That's a correct answer also. But now you're at a negative here. You could go to this valley here also and write the exact same thing. 2 minus 3 cosine 2 theta minus 120. That takes me to this valley value here. That is a correct solution. Suppose you went to this peak over here. This is at 210 degrees. And you wrote this as theta minus 210 degrees. That is a correct solution also. Because I'm at a peak or a valley. Okay? If I started on the prime axis, then it would be a sine curve. Since I'm at a peak or valley, it's going to be a cosine curve. Suppose I wanted to do some mathematical work, and I wanted to use this value right here, which is 15 degrees. I could write the equation y equals 2 plus 3 sine 2 theta plus 15 degrees. And that is the correct solution. Suppose I wanted to come over to here and do 165. I can write minus 165 here. That is a correct equation. But since now I'm on the prime axis, I have to use a sine curve. Since I'm using peaks and valleys, I can use cosine. That's why I say, if you go to a peak, it's always going to be a positive cosine. And that's easier in the brain. I just remember to use a peak and a positive cosine. Let's see, we have 1, -1, -2, and -3 we bottom out at. All right, draw on your prime axis. Where would you draw on your prime axis? Once again, I need to go equal up and equal down from that prime axis. So draw in your prime axis. That will be your vertical phase shift. You're still trying to find all this information. Amplitude period, vertical phase shift, horizontal phase shift. But we have a B value we have to consider now. So draw on your prime axis, equal up, equal down. Determine what the amplitude is. So you draw on your prime axis, find the amplitude. Check those with somebody around you. Go from peak to peak or valley to valley. Find the period. Once again, you could go peak to peak or valley to valley. Does not matter. Once you calculate the period, calculate your B value. B value is calculated by 360 divided by the period. Okay, then your vertical phase shift, go to your nearest peak, go to a peak. Now you might have to do a little work to get to that peak value, but you can play your games of halves. Okay? I don't give you a degree measure for the peaks there, but play your games of halves. I got a 90 here, I got 0 here. What's my games of halves to get to me give me my peak? Okay? So what's your horizontal phase shift have to be then? Or if you want to use a valley value, you just have a negative cosine curve, which is fine. Once again, there's oodles and oodles of noodles of correct solutions here. Yeah, write one. Write an equation down. You pick down you pick an equation that you want then. I said there is an infinite number of solutions here. There's just not one correct solution. Bless you. Right, let's see. We take a look. Where you draw your prime axis in, Bryce? -1. So our vertical phase shift is -1, which gives us an amplitude of what? 2. Okay, drawing our prime axis at a value of -1. Gives us an amplitude of 2 then. Okay, if we take a look at the period, Brandon, what's the period? If I go from valley to valley, or valley to valley is probably easiest here because I give you values there. 90 degrees. So the period is 90 degrees going from 0 to 90 or -90 to 0, which means the v value then has to be what? 4. 360 divided by the period of 4. Okay, vertical, horizontal phase shift. You choose what you want. If you play your games of halves, we have 45 here, we have -45 here. That is fine. If you use one of those, where we have y is equal to vertical phase shift, -1, plus the amplitude of 2, cosine 4 theta minus 45, or even plus 45 there. Did anybody use -90 and 90? The valleys? If you did, y equals -1 minus 2 cosine 4 theta minus 90. That is fine also. If you wanted to continue to go, let's see, that's 45. This would be 22.5. That would be fine also, and use a positive sine curve. Go do the last one here on the back side. Nice thing about these, you don't have to worry about the y-intercept here. Doesn't pertain to the equation. Okay, drawing your prime axis. Find your amplitude. Calculate the period. Find a horizontal phase shift. Get an equation down. Check your answer with somebody around you. This one gives you a little bit different ideas to think about. You can still follow the same method of madness, but if you start to understand what we're dealing with respect to graphs, you might throw something different down here. No, don't have to. If you want to, you can, but not necessary. Warming up, isn't it? Sun comes out. Okay, if you take a look here, Janae, what do you have for vertical phase shift? 0, that's correct. Okay, we go up 2 and we go down 2. So our prime axis is just our normal axis, so we have no vertical phase shift then. Okay, we have no slide up and downwards. Amplitude, what do we get, Hallie, for the amplitude? Okay, we have 2 up, 2 down. Okay, the period, if I go from valley to valley or peak to peak, does not matter. Braylon, what's our period? 720, which means our B value is what? 1/2. We have 360 divided by 720. 360 divided by 720, so our B value is 1/2. Now the horizontal phase shift. Okay, if you go to 540, that's fine, or negative 180, that is fine. That takes us to 2 peaks, and that's okay. So we have y is equal to, we have no vertical phase shift. We don't have to throw the 0 in there. 0 plus the amplitude 2, cosine 1/2, theta plus 180, theta minus 540. Both of those correct. Did anybody use a horizontal phase shift of 0? Did you? What's your equation?
Y equals 0 plus 2 sine 1/2 theta minus 0.
Okay, and once again, the zeros can go away, so we don't have to worry about that. The only problem is, okay, one problem with that is, he did a horizontal phase shift of 0, which starts us right here. But we go down first. What should we throw with the amplitude? It should be a negative. So y equals negative 2 sine of 1/2 theta is a correct solution also. Don't need the plus or minus 0 in there. Okay, this should be a negative since it goes downward. This is correct also. Neither of these are incorrect. All of them are correct. Okay, so, and that mindset is, oh, I need to get that one answer. No, there's not just one answer. There's an infinite number of answers that are there. And that's what I will grade you on when you have a quiz over this material. I will grade you on, okay, did you do the correct things in regards to having a correct equation that matches the graph? Your homework is Tuesday's assignment, which is page 54, 9 to 17. Okay, 9 to 17 on page 54. You're just looking at graphs now. You have equations or you have a graph there, and you're determining the equation. Okay, where this will come from, where this will go, tomorrow, Thursday, we'll have a worksheet that incorporates all this stuff together. Friday will be an in-class assignment over this material. Monday and Tuesday will be review day and quiz next week over graphs of sines and cosines. Questions you have? Once again, very good job in regards to just progressing and being patient with the process here. You seem to be picking up the material as we go through it, and that's exactly how it should be. You start slow and you continue to work through it and you continue to push through it, and your knowledge continues to get better and better as you go through it. Questions? QED, how's it done?